Okay, so we're doing 6.4 numbers, ready, set, go, number 7. And what we're trying to do here is we're trying to figure out the relationships that happen when we have this kind of picture. So there's a theorem that we just went over in, hold on a second. So the theorem that we went over had to do with a triangle and then parallel lines to that triangle, one of the sides. Okay, so obviously here you see that these lines are parallel here. These 3 lines are parallel. Okay, so what you basically need to know, whenever you have parallel lines, they cut segments up proportionally. Okay, they cut up segments proportionally. So there's all of these proportions that you get. So one of the easier ones that you can kind of look at have to do with sides of the triangle or parts of the sides of the triangle. So, like literally, you can write a proportion like this. Do you see this proportion? Y over 10 equals 9 over x. That's one of your proportions. So y over 10 equals 9 over x. Okay. There's another proportion that you can get, which is like if you unnest those 2 triangles, like if you draw those 2 triangles out like by themselves, right? Like this-ish, I don't know. That's not a very good picture, but you get what I'm saying. Where this is y and this is 9 and this is 7. And this side right here, I'm pretending is this side right here. So how long is this side right here? How long is this side right here? Look at this, right? This side here is this side here, is what I'm trying to say. No, it's y plus 10, right? So it's y plus 10 because it's like if you were a tiny little ant and you walked from here to here, you walked y feet long, right? You walked y feet. And then you took a break, I don't know, you had a snack, and then you got up and you continued. Then you walked 10 more feet, right? So how much did you walk all together as a tiny little ant? Y plus 10. So then this would be, this would be y plus 10. Does that make sense? So similarly, how long would this side be right here? How long would this side be? Yeah, very good. X plus 9 or 9 plus x, it doesn't matter. Right? And so now because you know that these 2 triangles are similar, and if you don't know why they're similar, the easiest way is AA. They share this angle here and here. And then because these lines are parallel, you get corresponding angles here and here. Right? Right. So those 2 triangles are similar. So now you can write another proportion. Oh, and this is Z on the bottom, right? So then you can write another proportion as in y over y plus 10 equals to 9 over x plus 9. Does that make sense? Okay. So there's another proportion that you can write. Y over y plus 10 equals to 9 over x plus 9. Now, some of you are tempted to cancel these 9s out. Don't do that. That's wrong. You cannot do that. Mathematically speaking, you can't do that. Okay, so don't do it. Ms. Johnson, why can't you do it? Plug some numbers in here and then you'd see why you can't do it. Okay, so if you look at this, this is a system of equations. I have 2 variables with 2 unknowns and 2 equations. So I'm just going to solve this. Let's see. Is there any other way that I could possibly do this? Let's see. I'm looking for another. Oh, there's one more proportion I can write. So there's another proportion that I can write. And if I just go in here like this, do you see that? This over this equals this over this. Can you write that proportion out? This over this. Go ahead and write that proportion out. So what is that? Give me that proportion. You can't cancel these y's. Someone said, hey, Ms. Johnson, can you cancel these y's over here? No, you cannot. Right? Okay, very good. Thank you for the proportion. Someone said, Ms. Johnson, we could write, let's see, down here, 10 over 6 equals x over 8. Exactly. So this is a really good proportion to start with, because this one has two variables, two unknowns. The one at the top, the y over 10. This one has two variables, two unknowns. This one has two variables. We want to find an equation or a proportion that has one variable. So that's this one. Okay. And the way we solve this is the easiest way is just to multiply by the least common denominator, right? So here, in order to get rid of this 8, I'm going to multiply by 8. And do you see how the 8s are going to divide out? 8 divided by 8 is 1. So I can't just multiply on one side. I'm going to multiply on the other side. And so now you can kind of see how they divide out to be 1, right? What would you multiply on this side to get rid of the 6 so that it divides out? What would you multiply on this side to get rid of that 6? Right? I'd multiply by 6. Very good. So here I'm going to multiply by 6 on both sides. Right? And so now you can see these 6 divided by 6 is 1. So what do you have left? 8 times 10, which is 80. And x times 6, which is 6x. And then now I've brought you back to 6th grade and you can solve this equation, right? You guys remember how to solve this? How would you do this? Yeah, just divide. Very good. So I'm just going to divide out by 6. So x is equal to, and then this is not a whole number, so I'm going to simplify the fraction. 80, they both have 2's in it, so this would be 40 over 3. So this is 40 over 3. So there's one answer. So now I'm going to put them back in my thing over here. I'm going to say 40 over 3, which is about 13.3 with a little hat on, right? Okay. Okay. So now that you know that, now you can use these other proportions here and here to find your x and to find your y and your z. Does that make sense? Okay, I'm going to pause it right now. I want everybody to find their y. Okay, so I just realized that I didn't have to multiply by 6 this. I was doing extra stuff, and so some of you are confused on that. I really just needed to multiply by 8, and then my answer would have been x equals 80 over 6. And then there's my answer. So to find y is very similar. I'm going to plug in this fraction into x right here, because then that's just going to make my life easier. You can plug in the 13.3 if you want, but I'm not going to. I'm going to stick to fractions because I like them better. So I get y over 10 equals to 9 over 40 divided by 3. Don't worry about this weird looking fraction. His name is complex fraction, okay? Just so that you know. But if you remember from 6th grade, the way you get rid of dividing by a fraction is you multiply by the reciprocal. I'll do that in a second. But first I want to get rid of this 10, so I multiply both sides by 10. So I get y is equal to 90 divided by 40 over 3. So the way I get rid of that is I multiply by this guy's reciprocal, so 3 over 40. Right? And then I go, 90 times 3 is 270 divided by 40. And then I'm going to simplify by dividing by 10. So that's 27 over 4. There goes your first answers. A lot of you got that answer, which was great. Okay, for the z, you could have written z in many different ways because it's part of many different proportions. Okay, I'm just going to take this part of the proportion. So let's do y over y plus 10, which we already know what y plus 10 is, right? We already know what y is equal to, actually, no, I can't do that. Okay, y over y plus 10 equals to z. Now, where does z go? Should z go on the top or should z go on the bottom? Should z go on the top or should z go on the bottom? Yeah, it goes on the bottom. Why, Miss Johnson? Because z is part of the same triangle that y plus 10 is. So you got to put him in his spot. So z, and then that means that I'm going to put 9 on the top. Some of you talked about cross multiplying, which you can also do. It doesn't matter which way you go. So then I'm going to write my 27 over 4 on top here. So I'm going to go this way. So I get 27 over 4 divided by 27 over 4 plus 10 equals to 9 over z. And then I'm just going to solve that. Okay, I know this looks crazy. I know it does. So one of the things that you could do is you can multiply. I'll just leave it right now. So let's see. I'm going to remind you how to cross multiply. Cross multiplying is multiplying this guy times this guy and this guy times this guy, in case you don't remember that. So over here, we have 27 over 4z equals to, and I'm going to multiply this out, 27 times 9, whatever that is, plus 90, right? I'm going to leave it like that. And then to solve for z, I'm just going to divide by 4 over 27, or just multiply by the reciprocal. And that goes this whole thing. And now you understand why I left it like this, because you should see what's happening. So 27 divided by 27 is 1. 4 divided by 4 is 1. So I get z equals to, now I'm going to distribute this. So when I distribute this, does everybody see how it's 9? Like 4 divided by 4 is 1. 27 divided by 27 is 1. This is 9. And then when I multiply these two, both of them have 9s in it. So that's what, 10, and that's 3. So it's plus 40 over 3, whatever that is. So my answer, my decimal answer is 17.37. 17.37. Good. All right, let me stop this video.